Hello students, welcome to the video lecture of Principle of Programming Language. Today we'll discuss language in a depth, which is an important part of Principle of Programming Language of Unit 1. We have already discussed what is a language, why a language is required, what are the histories of this language, and how this language can be differ from computer language and how it is used. So let's have a look. Before that, I am Ashish Kumar Ratha, Assistant Professor from the Department Computing and Security. I have 17 plus years of teaching experience. I am a security enthusiast, specialist in blockchain and data security. I have published different papers, out of which 8 papers, which comes under different journals. So these are the outline of today's lecture. So if we see a language in a depth, we need to know why a language and what are the characteristic of that particular language, what should be the characteristic of that particular language. So the content must be simplicity, readability, clarity about the binding. We discuss what is binding and all. Reliability, what is the reliability, support, how a language support to be interpreted or to be um, interact with any devices or human being. Then abstraction, data abstraction, what you know in OOPS part, that data abstraction. Then orthogonality, how it is proportionately helpful, that we will see. Then efficient implementation, when we implement that language, how it is gonna be uh, implemented efficiently. For example, if we say you know your mother tongue very well, you if something has been given to you to describe with your mother tongue, then it will be easier for you. That type of implementation we are going to see. So in history we have already discussed in different era how the language has been developed day by day. Okay, so let's see the characteristic. The first characteristic is simplicity and readability. So it can be the characteristic. So the simplicity and readability. Simplicity means whatever language we are talking about or we are learning about, we try to convert the language wording form or language instruction form into a small set. If we take for example, here it is given as Java web scheme. So in Java instructions are very lengthy. For example, if we need a particular JDBC driver to be implemented or to be open, we need a JDBC object first. So that JDBC object name dot JDBC connect, then the connection name, then the database name. So we need a lots of things to be implemented. Okay, let's take an example of small instruction set of programming in C. CLRSCR, it is a function. CLRSCR, it is in console conio.h console file. So it is a small instructions. So in CLRSCR, the instruction has been written and it's clear the screen. Next one is simple syntax. The syntax should be very simple. What should be that? Likewise, in C++, we need the syntax as per the compiler. We need the syntax as per the JVM, Java Virtual Machine, Java compiler. So in C, if we write printf, then only the compiler will understand that it is a printout statement. In C++, if we write a cout, then only the compiler understands that this is an object of the stream, output stream, and it consider that object and execute accordingly the next statement. In Java, if we write system.out.println, then that is a output statement. So in Java, system s should be capital and it is a class. Then dot out, it is a object. Then dot println, it is an function defined inside the system class which can be used by the out object. But in Python, we can print a variable, value of an variable or a value to an object very easily. So, depend upon language, the characteristic simplicity should be that instruction should be small and syntax should be simple. Now, what is the benefit? When it is a simple and readability, we can easily learn it and we can easily do the programming. Clear? If you have any doubt, you can revert to me on my mail or in class, offline classes, sorry, classroom classes. So next, move to the next characteristic, clarity about binding. First one is clarity. So all of you know, clarity you are understanding, you should have clarity about the language. You should have clarity about the language. What is that clarity about the language? When we are speaking our mother tongue, whatever mother tongue it may be, when we are speaking mother tongue, we have clear idea about our language. So whenever we are doing the computer programming, computer language, we should know each and every element of that language and how the elements are binding. If we are saying that I have a pen, मेरे पास एक पेन है, so I am binding the verb, the object, the subject, the proposition clearly because Hindi is my mother tongue. Of course, Hindi is not my mother tongue, but those whose mother tongue is Hindi, they can clearly highlight the binding. So a language element is bound to a property at the time and the property is defined for it. So a property which is defined for the particular purpose, that particular property must be for that language element. For example, there are two things, vowel and consonant, and in Hindi also there are swar ban and vyanjan ban. Without swar ban we can't speak a word. Without swar ban, without vowels we can't speak a word. That is the binding of English language or Hindi language or any language. So in computer science also, in computer language also, there is a binding, there is a association between object and the property of that object. So if vehicle is a class and a car is an object, so acceleration is the function of that car, object car. So there is a binding of acceleration and car. Okay, so here is the example, a variable and its type, a variable and its value. Then early binding takes place at compile time and late binding takes place at runtime. Let's take this example, this a equal to 2. When we declare the variable a equal to 2, so a is a memory place whose value is 2 and its type is integer. Okay, then we just occupy some space in memory before the execution of the um, program, that is known as early binding. But at the time of runtime, when the value changes, when the new value assigned, that is called late binding. So there are two types of binding, early binding and late binding, for clarity about the binding. Next, move to reliability. As the name clear, the reliability, a language is reliable if program behavior is same on different platform. Early version of Fortran. So program behavior is same on different platform. For example, A equal to B plus C, we are giving an operation. That operation must be same in different platform. Then type errors are detected. If we made some mistake while typing the statements, that error must be detected in that particular language. Semantic errors are properly trapped. Semantic errors means syntax error which is semantically incorrect, that must be trapped properly. For example, C and C++, there is, for in C for printout we are writing printf, and in C++ we are using object. There we are using a function that is written inside a header file, that is conio.h, but here we are using a object which are written inside the stream class, that is called as cout. So this is the semantically difference between C and C++, that must be uh, properly distinguished. So if someone made some error, that must be handled. Then memory leaks are prevented. Likewise, C based Java. Why C based Java? C is static. Memory is not dynamically handled, and in Java, memory is dynamically handled. So there is no pointer concept in Java, but in C there is pointer concept in Java, where we are trying to use that limited number of memory in a dynamic way. Then language support. Language support means, let's say you learn a new language. So in the first page we are learning the alphabets. When we are trying to implement it, we are trying to speak that particular language, we are in search of words, vocabulary, that is called as language support. Okay, so in computer language, in programming language, the language support must be the language whatever we are using, that must be accessible. That means compiler interpreter must be there to interpret that language with the system. To learn that language, good text and tutorial must be there, and that language must be accepted by wide community. And irrespective of all the thing, a integrated development environment, an environment must be there to implement that language and to learn that language. For example, to learn C we need Turbo C or any C compiler who actually compile the C language. To learn Java we need language support, we need JVM, we need Java compiler in the backend of any language editor. Next one is abstraction in programming. So this is same as the data abstraction what we know in object oriented programming concept. So here the data should be programmatically defined within the classes or the class libraries. The data must be presented in that form, and the data must be handled through the procedure such as what we called as member variables and member function. Member variables must be handled by member functions. So this is the same data abstraction concept whatever they are in OOPS. That's why it is written programmer defined types or classes or class libraries and procedural. Okay, if you have any doubts, You can revert to me. Okay. So the language were designed to execute program efficiently. Next, moving to the next, orthogonality. Orthogonality means it is a features that has been built on a small and mutually independent primitive operations. So we can call this as a small amount of or a teeny keyword or teeny piece of a program that can be uh, provide its existence. Okay, if we take the example, if we take the example, uh, in computer programming, the operation change just one thing without affecting the other. Okay, if we take the example, Java language is quasi-orthogonal and C and C++ are non-orthogonal. Okay, then there are some other language, Scala, which is called as fully orthogonal. We'll see this orthogonality in detail in our later classes. Okay, so it has some future exceptional rule also and conceptual simplicity. So the more orthogonal the design, the fewer exception and the language rules require. So whenever the language design is concerned, the orthogonality come into existence. For example, C is not very orthogonal. There are two kinds of structured data types, array and struct in C. Struct can be written as value of functions and array cannot. Parameter are passed by value and except for arrays which are passed by reference. Next, move to the efficient implementation. It is the very important. So initially, when languages are designed to execute program efficiently, computer costing is million of dollars and were critical resources. It is very costly. But the programmers who can able to manage the memory efficiently, they are earning million of dollars. So we did not have a vaguest idea how the thing works. For example, Fortran language and compiler. We already discussed the Fortran language in our class in history part. The way Fortran language works with the compiler, that is not that much efficient implementation. So we stock out simply to optimize the program object. The running time, because more people at that time believed that they really could not do kind of thing. They believe that machine coded program, okay, would be terribly inefficient, that would be impractical for many application. If we take the middle of 1960s, if we take the example, by the middle of 1960s, when the previous quote was made, after the advent of Fortran, COBOL and Lisp, and algol, it has been already realized at that time that programming was changing and machines were becoming less expensive. Why it is less expensive? Because efficient implementation of inter, programming interpretation with the interfacing of systems and human being. Compiler technology matured in 1960s and 70s. Why it is matured? Because of the efficiency increases in the implementation of programming. That's why it is called embedded system. Embedded systems such as real-time responsiveness. Nowadays we are using navigations, weather forecastings. These are efficient implementations. Okay. Nowadays, artificial intelligence application that has been implemented efficiently. For this implementation, the first thing we see is computer capabilities. So computer has evolved like anything in last few decades, last 10 years or 20 years. It starts from 1940, 45, 1940 to 50, and after that it's updated and developed like a boom. Then some computer applications, nowadays apps are there. We can call that web applications. The way it is responsive to users. Then comes programming methods, the way language design, the way the designer designed the language, the way the program works. Language design have evolved to reflect our changing understanding, the good methods for writing large and complex programs, and to reflect the changing environment. What is the changing environment? If we go few years back, few years, just to 5 to 7 years back, we need to write some programming code in some compiler, offline compiler, standalone compiler, or IDEs. But nowadays, if you want to do some machine learning, want to do some complex task, you can take the help of cloud. You can take the help of Colab in Google. You can do that program execution in cloud memory. You can use that memory. That is one type of efficient implementation. Then theoretical studies. The theoretical studies must be implemented efficiently, or the theories whatever made, that must be using some mathematical formula, which come to a standardization of implementation. When it is standardized, the implementation in web based, in cloud based, that has been comes to a efficiency level. Okay, now what makes a good language? Mechanism to design high level language must be perfect. So nowadays the AI application come into existence due to this. We do not have to think more. We just give a query and AI giving the details. We do not have to design a application file, such as if you have to design a PPT. AI is there. You just have to give them topic. The AI design it very well. Okay. If we say the design implementation of different language, so in 1951 to 55 it was very poor, then it is quite developed in 56 to 60, then 61 to 65, then 66 70, likewise it is developed. So a programming language must provide both conceptual framework for thinking and algorithm. So in efficient implementation, it is quite very required to get the comprehensive idea. Then why a language? What is a language for? A language must be clear, simple, and unity. The way of thinking, the expressing the algorithm. Normally, a programming language is nothing but it is the way of expressing the algorithm. Okay, then it must comes with the syntax of language that affect the implementation part or that affect the writing part, that affect the testing part, and the most important in modification and understanding. The readability of program in a language is a central issue here. Then syntax is that particularly terse and cryptic often makes a program easy to write. So in today's class, what we have learned, just going back. So we have learned the different characteristics such as orthogonality, clarity, simplicity, readability, reliability, efficiency, then data abstractions. These should be the language characteristic to design a language, and that language should be designed to make the programming more easier, coding more easier. If you have any doubts, if you go through these videos, if you have any doubts, you can ask me in offline classes or in the class. Okay, this is all about. If you have anything, do ask me. Thank you. Have a good day.